All right, so today we're starting lesson 1.4. We're just doing the first part. There's going to be lots of exploring, lots of Desmos for today. And so the target when you leave is to understand that a single statistic to summarize a data set is not always sufficient for drawing conclusions. So what is a statistic for a data set? It's kind of like when I ask, what's the mean? What's the median? What's the mode? So you kind of can already logically know that you can't just look at one of the numbers, right? They're all important. So we can't just base it off of one. And so keep that in mind as we explore today's problem for the paper you have, okay? All right, let's move forward. Okay, everyone should have their golden paper. I'm going to give you about a minute to read the delivery problem right here. So everyone, grab your golden paper and you're just reading the first paragraph, okay? I'm going to give you about a minute, okay? All right, so based on what you read, what kind of, just as a class together, what kind of data is presented in the problem? Is it categorical or quantitative? Fifth grade? Categorical or quantitative? You gotta remember that's from the first. Quantitative, okay? Remember categorical is more like categories, like words. Okay, so it is quantitative. And what is that quantity? Like, what are we looking at? Yeah, who, how, early or late, who is? The deliveries, what are they delivering? Food, okay? And then what statistics can you determine using the data? Well, what is the problem asking me? Let's go back. What is the problem asking me to decide? Yeah, so everybody underline this part that I have highlighted on your goldenrod paper. The moderator wants to choose one delivery service this year and asks you which company is better. Okay, so underline, that's our goal. For the next 3 days, we're going to be making our final decision on which company is better, either company A or B. But today is just a day to explore. So if today you choose company A and tomorrow you choose company B, that's okay. Or vice versa. If today you choose company B, but then tomorrow you're like, no, A is better actually. That's okay. It's okay if you're not correct right now. All right, just want to give that disclaimer. Okay, so in order for us to decide which one is better, today the first thing we're going to look at is the data display. Okay, so what kind of data displays can you create for this type of data? Just shoot out. Which ones have we done? Data displays. Histogram, what else? Box plot, good. One more. Dot plot, good. Yeah, those three. Okay, you can do whichever one you want. And then that's what you're going to do on this next part. Create one data display for company A and one data display for company B. Now, it's your choice if you want to do all three or if you just want to stick to one. But when you're comparing the data displays, try to compare the same type. So, like, don't compare a histogram for company A and then a dot plot for company B because it's not the same. So you want to be consistent with the comparing. But if you want to compare all three, you're more than welcome to. I'm putting a timer on the screen. By the end of the timer, the goal is to give me an argument which company you would choose, A or B, which one you would prefer, okay? Now, for the data, let's look at the data right here. So you're going to create two lists. List one is A, right? But then your second list, do not name it A because it's going to, Desmo's not that smart. You need to name it B for your second list, okay? And then another thing before we keep going, what does it mean to be 3 minutes early? -3. Thank you. That's perfect. So if you're early, you didn't wait 3 minutes. You waited -3 minutes because it was early, okay? So when you're typing these data sets, this is not 3. What is it? -3. So anytime you see the word early, you were actually -3 minutes waiting because you showed up early. Okay. So company A should have 20 entries and company B should have 20 entries. Everyone should be on Desmos right now typing your data entries, okay? Okay, if you're stuck and you're like, I know how to create this, but I don't know what to do next, remember, you're trying to compare the way the data looks so that you can determine who was faster or slower with the deliveries, okay? So how can you determine how much faster one time is than the other? Okay. All right, so here's the data display for B and for A. Does it look similar to yours? Yes, everyone? I have them all three on top of each other, but there's the company A and company B. So the next part is with your, on page 16, sorry, everybody turn to page 16 on our ISN. You're gonna title it Standard Deviation on page 16. So everybody turn to page 16 and write your title, Standard Deviation. Okay, we're gonna do some responses in our notebook for this. Okay, page 16, Standard Deviation. All right, here are the questions you're answering. For question number 1, what information is available from your data display? So talk to your table. What's available to you? What could you tell me from the display? And then what is not available? So what's something that you can't tell from the data display? So could you tell me the average of the wait time? Could you tell me how often are people waiting? Does that make sense? So anything, just jot something down for number 1. What information could you tell me from your data display? Just any information. And what's something that you probably couldn't tell me from there? Somebody said, I don't know if there was traffic on their way to the delivery. And yeah, that's something to consider, but we're looking more at quantitative data right now. So what's something that's not available and what's something that is available? Okay, just take a few minutes to write something down for that, okay? Okay, raise your hand if you did a box plot. Box plots? You? Okay, raise your hand if you did a histogram. Good. And then raise your hand if you did dot plot. Dot plots? Raise your hand if you did all 3. Nobody did all 3? Okay. All right, the next part is, no matter what you picked, each one is going to tell you the information you need to know, right? But we're going to look closely at the measures of center and variability. So the measure of center, we already talked about that. That was when we did the balance, you know, when we added the deviations and it was supposed to equal 0. Okay. Where is the center area, central area for the box plot? Everybody, let's review. Which part? What do we call this? Interquartile range. Thank you. Okay, good. This is the interquartile range. This is the measures of the center. And then what about the variability? Do we know what variability means? Anyone? What does it mean to have variability? You want me to Google it?
Variety?
Yeah, variety, like the spread. Okay, so I'm not an English major, so sometimes we can Google words if we don't know what they mean. Okay, but just make sure you read it in the context that we're using it. So what context are we using this word? geometry stats, right? So the first definition says lack of consistency or fixed pattern. It varies or changes. So if you have variability, that means you're very inconsistent. Sometimes you're high, sometimes you're low. But in a more statistical area for math, see right here where it says in data, it measures how much individual data points differ from one another and from the central value, indicating a lack of fixed pattern or consistency. So a lack of consistency. So in our displays, let me pull them up. Here's company A. Would you say this company has more variability or less variability? More. It's very spread out, right? Good. And then what about company B? Less. So that means who's more consistent? B. Yes, with their wait times, right? Now, what could you argue for company A, even though they have more variability? How could we argue for them and say pick us instead of B?
They're a lot earlier than what?
Yeah, they show up earlier way more frequently, right? So let's write that down on our notes. Finally, on the goldenrod. So company A fulfilled more deliveries early. And you could see that on the table, right? They have way more entries that are early than late. Yes? Okay. Good. All right. All right, everyone done writing? Okay. So, yes, they did have more early entries. Now, if we look at the variability for, I'm looking mainly at the box spot here. We already said who was more consistent. Company B, can y'all see how the interquartile range is smaller? And for the histogram, it's not as spread out. It's more what? Yeah, compact together, closer to the center, right? And so, what argument could we say for company B? They're more what? Consistent. They have less of a range. They're not all over the place. They're consistent. Okay? So, company B had more consistency and less variability. That's the word we learned today. Okay? Did it help y'all that I googled variability? Would you have done that? No? Did y'all already know what variability is? Kind of. It's okay to Google words sometimes, y'all. Okay? So company B was definitely more consistent and less variability in the spread. Okay? Alright, so we made an argument for company A and for company B. Now the actual decision needs to be made. Who's better, A or B? Could you make a choice? Raise your hand if you choose company A, because they had more early times. Okay, and then company B, they're more consistent. What's the right answer? We'll find out tomorrow. Stay tuned at 8/7 Central. Yeah, no, we will find out tomorrow. I'm just kidding. What, as a company, what do I want more? Consistency. So who should I be picking? B. Yep. So you want to be a business owner, Frank? You want to be a business owner? No? Okay. Yeah, no, you want someone that's more consistent rather than all over the place on their delivery times. Okay? All right, tomorrow we're going to explore more the actual calculations of the standard deviation. And so you can, don't glue the goldenrod yet, but you can keep up with your table of contents. I'm going to post the updated one. Yes. So here's the updated table of contents.